I was getting ready to do this video and my phone went off with another Amber Alert. Last night there was an Amber Alert. They did find the girl. Um, and my phone just keeps doing the Amber Alert. And I guess I had to hit the button for dismiss. So finally it stops torturing me. So I have the phone off so it won't get me. But this morning I put my computer on and Windows is doing an update. And I'm having trouble in my PDF uh, file trying to read a certain number for an offset that the guy used. This project has been done through really bad hot weather, possible storms, 3 tornadoes came through. Uh, Everything about this project has been a nightmare. I want to show you something. When you turn it on, normally when I turn on this oscillator, it drifts incredibly for first few minutes. Notice it's staying pretty well stuck. Okay, it's bobbling at the end digit. Okay, got it done. It locks. Now, what exactly happened? All right, to start off with, these Huff and Puff oscillators and circuits, they're made for, let's say, the UK, Belgium. Um, They're not made for the United States, so I wanted it for 80 meters. Just say 80 meters is 3.5 megacycles or megahertz to 4 megahertz. Okay, you get the I think it's a 75 meter band in there. Well, anyway, that's what I want to do. It was just a project. I said, let me see this thing work. Well, the first thing I realized was the circuits weren't made. None of them were made for 80 meters. And I did find that one holy grail. I showed you that. And that guy had such a big offset on his receiver. Now the offset is you have the frequency of the oscillator running at a certain frequency. The incoming signal beats against it. It produces an IF. Well, his IF was 4 megacycles, up in that range. I don't have the exact number because I just had trouble with the PDF viewer. But anyway, so he's actually operating at 7 megacycles, his circuit. So all the values he shows you for 80 meters really aren't for 80 meters if you build a receiver in the United States that uses 455. And I realized this after a while. I was like, oh crap, I'm still going in circles, you know? And let me see if I can find the real quick here. You know, you never can find anything when you want, when you got a lot of pages. The 4060 that's shown in this unit. Okay, let's see if it whites out today. That's good today. Okay, this 4060 divides the incoming frequency. Okay, and the 4060 doesn't give you all the outputs you want. Now, I used the divide by 10, which is really labeled a divide by 11. Okay, you got to be real careful with some of the way companies call flip-flops inside of a chip, because some start at 1 to 14 and some say 0 to 13. There's a lot involved in this. This is a steep learning curve if you want to build this Huff and Puff. Now, I can tell you, here's the front end I used. You know, you got to amplify. I use this section right here. Okay, 2 transistor amplifier. That brings up my VFO oscillator. But also, if your VFO oscillator doesn't have a buffer, when you add this circuit on, it's going to add capacitance and it's going to lower that oscillator on you in frequency. And you'll go, oh, I can't believe this. Well, that's what I found. Okay, I kept saying, I can't believe this is happening. Okay, the other thing is, since you go lower in frequency, you're going to have to, here's the varactor, okay? And this guy used a regular varactor. And that's what, when you go lower in frequency, you can't use an LED diode or other. You're going to have to get some type of varactor that's either 30 picofarads to 70 picofarads, in that range, okay? And then the output off the varactor is going to have to be 30 picofarads to 40 picofarads. It's not going to be 5 or 10 picofarads. Because you're operating at a lower frequency, okay? And it's very easy to get the circuit to lock at the lower frequency, but you got to have the right values. Now, if you look at the circuit, you'll see this circuit here I used, and this is a XOR gate, XOR. Well, anyway, it's an exclusive OR gate. All right. And what's wrong with this circuit is it gets its 5 volts from one of these outputs of the shift register. When it's high, it gets its power. Well, that's not really that great. And what's really bad is you have to feed the output of that transistor into two, in this case, 22 microfarad caps. Well, when you do a lower frequency Huff and Puff, you're going to have 100 picofarads. Well, this thing really doesn't drive this good. So you got to use a 74HC86 exclusive OR gate. Just one gate out of the package. So it's going to add an extra IC, big deal. Okay? But that's some of the stuff I ran through, is the fact that exclusive OR gate, it's actually called DTL. You use transistors and diodes. That doesn't have enough oomph to control the 100 microfarad output capacitors that smooth out the error signal. Okay, and you're going to go going crazy because you're operating lower in frequency, and all these circuits are for another country for higher frequency. So the values are all different. Okay, and I say the divide by is going to be less divide bys. The higher in frequency you go, the more you have to divide the incoming signal before it goes into the shift register. Okay, I was going backwards. I was going lower in frequency and I was adding more shift registers, and that's the first mistake I made. But like I said, there's a learning curve. There's very little real information for this thing on the internet. Oh, and a lot of people just copy. There is supposedly a mistake. You'll see this thing here in this circuit. These two resistors are 4.7K. On one of them, they're 4.7K. On some circuits, they're 47K. So there's been discussion, if you dig around, what the real value should be. I'm telling you, get yourself a 74HC86 and use the exclusive OR gate in that chip. Okay, and you'll have more oomph out of that chip to drive your center tap capacitors, which that's actually the correction signal that comes around and drives your let's see, it comes out this way. It goes off the page. My printer didn't put it in. It comes over here to the vari cap. Okay, so this circuit, now that I got it working. Oh, and the other thing, turn it on for at least a minute before you set the lock, and it'll stay good for hours. Okay, if you do tune it in right away, your oscillator may shift so much that it makes it unlock. Okay, and yeah, here goes the siren now. You probably don't hear that, but anyway, it's just I get easily distracted, and but yeah, that's the things you're going to go through in life. Is this circuit here was a lot harder than I expected, because it was designed for a different country, and then I figured, oh, it won't be nothing to it, and well, there was more to it than I expected, and you know, it's a steep learning curve. I had to learn how the circuit worked. I had to do a lot of reading, and it's not worth it. Okay, yeah, I have an oscillator now that doesn't drift. To put into a radio that there's really not that much to listen to, but I had never seen this type of circuit with error correction, and it's the predecessor before like phase lock loops and DDSs. So in other words, if you're really into electronics, you really love circuits, you're going to want to build each one. And that's why I get so aggravated. I have fights with people when they start throwing stuff at me. I know they've never done the work. Okay, I do the work. It's very painful to go into a situation, into a circuit where you're expecting just to wire it up and have it work. You know, you sort of know how it works. Overall, you know, as the frequency goes through, it comes in, it gets divided up, it goes into a shift register, and the shift register has a reference oscillator going into it, and out comes a correction signal. And then what happens is that correction switch goes over to a varactor diode, and it changes the frequency of the oscillator to keep it on track. Very simple concept, okay? It's sort of like the DDS. It's sort of like phase lock loop, okay? But you've never seen one work before. So you can just read the couple sentences, memorize them, and repeat them back like a parrot, or you can actually build the circuit and go through the painstaking problems of maybe you put a wire in the wrong place, you got a component in backwards, or maybe it's the circuit itself, the person didn't draw it right. I've gone through all this stuff. I stay with stuff. I keep reading. Every time I encounter a problem, I go and read, and I find that someone else has had the same similar problem. And that's why that Holy Grail one I tell you about, that one, the guy goes through it. I had this problem, I had that problem. And he had the problem because he had such a large offset on his oscillator for his receiver that he was in a different frequency zone than the guys in his own country. But also, he wanted to get 80 meters in, I think he said he was from Belgium. He likes 80 meters. I like it too, okay? There's always somebody on 80 meters at night, unless the weather conditions are like totally bad. But there's a variety of things around 80 meters that you can bump into. And that's what he wanted. And he started figuring out, and then he wanted to be able to have a switch and switch between bands. And then later on, he come in with plug-in boards because he found that was the easier way to go. And some people, they want switches. I want to be able to go from here. I want to go be able to there. Really, when you're working DX, you're staying in one little area. Oh, go away, go away. You know, there's always that one guy that has to have everything. So in this circuit, you're building it to understand how it works, to see it work. And I just got a little bit more than I bargained for. Okay, but stay away from the 4060 chip. If you go into this, get the I think it's CD4040 they use. That allows you to have 12 outputs that are in a row divided. The 74HC, yeah. So what do we need? A 74 HC 4020 4040. Got to put my glasses on. Yeah, that's the other part about being old. Okay. Yeah, you want to use a 74HC 4040. Okay. This one lets you have, it's a divide by 12, and you can have all the outputs you want in a row, so you can do some experiments. The 4060, that chip there has some of the, they don't bring all the 14. There's 14 dividers in it, flip-flops, but you can't get access to them. Now, I was lucky enough to get the 10 to divide by 10, but it's actually marked 11 on that manufacturer. On some of the spec sheets, it's marked 10, okay? And some it's marked 11. This is just the way they count. You got 14 flip-flops in a chip. So it could be labeled 1 to 14 or 0 to 13. It's just, when you're in this electronics, after a while, that doesn't bother you. But where it gets to you is when you have to make a change, and now you can't access the divide by. So in other words, the 4060 won't let you do, by throwing a switch, you can't go from 80 to 40 meters, okay, because you can't get the divide by that you need to make that work. Because you could make, with a little switch, you can make a unit that does 80 meters and 40 meters, okay? If you really get into this, I really got into it from the aspect of seeing it work. And there's so many things, like when you go to take the output off your oscillator, some oscillators don't have a buffer. So as soon as you hang on that circuit to bring it in the VFO to your circuit, you're loading your oscillator down and you're changing the frequency. You're adding capacitance, okay? There's so many things, because this is not a beginner circuit. This circuit pushed me to the limits, okay? That's why I stayed with it. You know, I could say, oh, what a piece of junk. I did say that so many times, but I knew that I would stay with this until it became super painful and I'd finally get it. Now in my mind, I've already started to build a second one. I already got the perf board cut out and the holes drilled in the corners and the chips all laid out and the parts. And, You know, this way, if I build a second one and it don't work, I can at least go back to the first one. But I got a pretty good knowledge on how this thing works now. And like I said, when you know it's working, it stays locked right away when you turn the power on. Oh, and if you set it for frequency at night and it stays locked and you shut the power supply off, the next morning when you put the switch back up, it's not going to come up on the frequency you were on. Okay, that's one of the things, and it'll be locked on the frequency it does come up. That's just one of the quirky things of a Huff and Puff. It sends correction signals to an oscillator to keep it on track, but you've turned the dial all the way up and down the band, and it stayed tracking and locked. And now when you shut it off, the correction signal is going to go to zero, and it's going to let the oscillator go. So the oscillator cools down. Next time you turn it on, those two won't be in sync with each other. You're going to have to readjust the oscillator. That's the one thing what's different with the Franklin. You turn the Franklin on, the first 30 seconds it's drifting really fast, and then by a minute or so it really starts to stabilize. And but if you tune in a signal like a guy on sideband, and you tune him in, and then you shut the receiver, the power off, and then later on you turn it back on, and you just wait a minute or so, you'll hear him come back into you'll hear him come back in and be clarified, or he'll be synced again. Okay, and that's because your oscillator goes right back to where it was when it warms up. And this thing doesn't do that. It doesn't work like that. And there's different ways to make the different locking points so many hertz apart from each other. It's a long, steep learning curve, and it's really a good circuit if you really like a real challenge. Now, in my case, I told you, I wasn't looking for a challenge. I just wanted to see this thing work. Now, if the original circuits had said for a 5 megacycle handband in the UK, I would say, okay, I'll build it for that. But I built it for 80 meters, and right away I'm like, I can't get this thing to work with 80 meters. What's going on? And I'm like, maybe I should figure out what frequency it's really for. Some of the circuits, they don't tell you what frequency they're for. Okay? They're just like something like this. There's no mention on this entire page what frequency this is for. Okay? Now, in this case, this is a divide by 12 output. So that's telling you it's a lot higher than frickin' 80 meters. I think that's it. I hope you've enjoyed my series on this thing. If you really want a challenge, this is it. And don't forget, you got to have a really good power supply powering that circuit board. Okay? It's got to be a real clean, stable 5 volts. And it's got to be deglitched for high frequency, and it's got to have at least 1,000 microfarads on the output of the circuit, the 5 volts, because who are we going to call them? CMOS chips really like to have a nice capacitor across the B plus, but also they want some deglitching caps to get rid of the high frequency that might be running around on the 5 volt line. It's something that comes with a lot of experience with dealing with from TTL to CMOS, and a lot of the modern chips still need that 0.1 deglitching cap. Okay, and I've told you everything I think I can tell you about this. The rest is up to you, whether you want to get this deep into something. And there are people that have started this circuit, and I know right away what happened was they're expecting it to work on 80 meters, and it doesn't work. It only works on a range of 1 megacycle range of a band, and then you have to change the divide by, and in some cases you got to change the varicap. That's why if you look at the Holy Grail one, he explains all that, but I warn you, he's using a large offset on his oscillator, so he's really up in frequency. He's up around 7 megacycles. Okay, he's not down at 3 megacycles. He's up at, his oscillator's running at 7 to get 3.5 megacycles. And once you understand that, that's why his values are much higher than yours. Yours are going to have to be lower. Your varicap, you're not going to be able to use an LED as a varicap. You're not going to be able to use a 1N4001. You're going to have to actually have a varicap. All right, that's it. This is it. I think that's it. All right, that's it.